quadrilateral because they still meet the 4-side criteria, but they are not parallelograms. Why are these not parallelograms?
Because they don't have two pairs of congruent.
Because only one pair of opposite sides is parallel. In a parallelogram, what's our definition of a parallelogram? Both sides must be, both pairs of opposite sides must be parallel. So we've got two types of trapezoids. We've got non-isosceles trapezoids and isosceles trapezoids. Where have we seen that word isosceles before? Squares
Triangle.
and triangles. And what kind of triangle was an isosceles triangle?
A triangle that had at least two congruent sides.
A triangle where at least two sides were congruent. Well, ladies and gentlemen, what do you think an isosceles trapezoid is?
At least two sides.
A trapezoid where my two legs are congruent, just like in a triangle. So for a non-isosceles triangle, we got a couple of rules. Only one pair of opposite sides are parallel. And then our second rule is that consecutive angles between our parallel lines are supplementary. These are our leg angles. Okay, so not the angles along the parallel lines, but the angles along the legs. And of course, isosceles got a lot more going on. So the consecutive angles between legs are still supplementary, but now we have our non-parallel sides, the legs themselves are congruent, just like an isosceles triangle. The diagonals of an isosceles trapezoid are congruent. The base angles of an isosceles triangle are congruent. Were the base angles of an isosceles triangle congruent? Were the base angles of an isosceles triangle congruent?
Yes.
Yes. So the base angles of our trapezoid are also congruent. And then opposite angles are supplementary. So this is almost, they almost repeat themselves here. When they say opposite angles are supplementary, well, it's because it still follows this rule up here. So if the base angles are congruent, well then obviously they're going to be supplementary to the two ones up top, no matter which direction we go. So let's take a peek at number 2. Is that an isosceles or non-isosceles trapezoid? For number 2. Non-isosceles. How do we know?
The two diagonal lines are not congruent.
So our two legs, they don't tell me my two legs are congruent. But what else in this trapezoid tells us it's not isosceles? Are the base angles congruent?
What are the base angles? What defines the base angle?
I mean, so these would be base angles in the same way that these would be base angles.
Okay.
So a trapezoid has two bases. You got a top base and a bottom base. So are either one of them congruent?
No.
No. So that would definitely say, hey, this is not an isosceles trapezoid. So what's the only rule we know exists? The leg angles are supplementary. So to find my leg angle, we're going to go to the measure of C. Plus 31 is 180. Subtract 31 from both. What is the measure of C? 149? Oh, what's wrong? And the same thing to find angle D. So angle D is a leg angle with angle A. So D plus 62 equals 180. Subtract 62 from both sides. So the measure of angle D is Angle D measures up to be what? 180 minus 62 is?
118.
180. Nice and basic angles. Well, of course, we can throw some algebra in there. What?
Stop.
Wow.
You're the math teacher, you can't stop.
I can.
I can and I will.
I would never stop. Mathematics is amazing. So we know the measure of Q plus the measure of R equals 180, because in a trapezoid, my leg angles are supplementary. So Q plus R equals 180. So we substitute who we know. 12x plus 3, 7x minus 13. So just a quick question. What if they had put angle Q down there? Could we solve this non-isosceles triangle if all we had was S and R?
Well,
Yes, you
How?
could,
No.
because the angles are so supplementary.
Are they?
Because 7x minus.
So let's see what makes these. Why are only these set of angles supplementary?
Because they're same side.
They are. So if I look at PQ and SR, those are my parallel lines, correct?
correct.
That would be my transversal, which would make these same side interior. Absolutely. But does that relationship exist there?
No.
Are my outside lines parallel?
No, I'm saying you could put 12x minus 3 and then angle P.
But do we know anything about angle P?
Sure.
Right? So that's what makes this relationship even exist, is our same side interior angles. All right, let's keep going. So we combine like terms. What's wrong, brother?
I think they must be all.
They must be parallel, yep. So 9x minus 10 equals 180. Add 10 to both sides. 19x equals 190. Divide both sides by 19. X equals 10. Is that what they wanted though?
No.
They wanted R. That's not too bad. That's a pirate's favorite variable. R.
That's gonna be, I think, yeah, that's gonna be a bonus.
What's the hardest favorite variable?
R.
Guarantee that people will get it.
It happens,
I
man.
don't think I've got
Oh no, he'll just remember not to say it in any of the.
No, people will
What's
say
the primary
R,
sugar
but
fruits?
he'll be like,
A
hey, you
pear.
gotta put the angle symbol.
A pair. It's
So 70 minus 13 is
17.
17. 57.
Wait.
What's wrong, brother? Talk to me, Goose. Let's talk about isosceles trapezoids now. TUVW is isosceles. If they did not tell me that was isosceles, could I assume?
No.
I can't.
You could, but you do.
I might be able to prove, but I couldn't assume.
Oh, no. No, that's, no.
All right, so we know base angles are congruent in an isosceles trapezoid. So what angle would T be congruent to? Ooh. What angle would B be congruent to? Double ooh.
So what's the next one?
well, we aren't sure
W
if
also
it's
equals
congruent.
47?
So in the next one, W has to be 47. Absolutely.
Are you
Are
giving
we
us like
sure?
rules on the
Yes.
No.
How
Oh,
are we? No, like,
oh, yeah,
no.
that makes sense.
How do we know it's isosceles?
Because there's a lot. Because it has the high, it has the deformities
They're both base angles. There's two bases.
Oh.
Oh.
Because the
No.
gives the hash.
Because those the other two are legs. You got two legs and two bases. Because the bases are the ones that are parallel.
Oh. So that means both sides are always equal.
Both base angles are always equal. Yep. So now that I know W and X, how would I find WZ? I mean Z or Y?
Well,
Scott, protein state.
yeah.
47.
Absolutely. Z and W are supplementary. So like you said, we're just gonna subtract 47 from both sides.
The Y.
You could do the Y and get the same answer, but you could either do it with X or W. Because opposite angles in our isosceles trapezoids are also supplementary. So we subtract 47 from both sides. So the measure of angle Z is
133.
133.
Also means that Y must be 133.
It also means Y must be 133. So angles in our trapezoids are kind of nice.
They give us those hash marks.
Yes.
You don't have to prove these either.
Okay.
Not yet.
Well, no, let's do the
Yeah.
whole like.
The proofs aren't there yet.
Number 11.
reason. No, they're
If
not.
JKLM is isosceles, find the missing angle.
Yeah.
Which relationship do we have here? Are J and M congruent or are they supplementary? They are supplementary. Leg angles are supplementary. So that means 10x minus 33 plus 4x plus 17 equals 180. We're going to combine like terms. So 14x minus 33 minus 17, what y'all got?
No.
Not there yet? 16? 15 maybe?
Yes.
18 maybe?
It's
16. And we're gonna add 16 to both sides.
uh-oh.
What's wrong?
Oh my God. I see where it is.
Okay.
Go subtracted 16.
Watch them pluses and minuses.
My God, that's
X equals 14.
X equals 14.
Yep.
Okay. But it wants us to find each missing angle. So I'm just going to plug in 14 for J and 14 for M because that's going to give me K and L as well. Because in an isosceles trapezoid, what's true? The base angles are congruent. So we got 10 times 14 minus 33. 140 minus 33 is?
Math.
Math. 107?
Mhm.
Yep.
Yeah.
Do the same thing for him. 4 times 14. What's wrong with y'all? Calm down.
So many.
Where's all about us?
Is that 76? 4 times 14? No.
It's 73.
4 times 14.
It's 73.
Finally,
73?
Correct. That's what I got.
So that means my top base angles are 107. So J and K are 107. And then L and M are 73.
So many colors.
All right, 13. CDEF is an isosceles triangle. Find the missing angles.
Some
So
people-
this time they gave me base angles. And what do we know about our two base angles? They are congruent. So if they're congruent,
Mhm.
we can set them equal to each other. Subtract 18x from both sides. So we then add 16 to both sides to get 21. Divide both sides by 3, so x is 7. Now we take that 7 and substitute it back in. So 18 times 7
Oh, let's go.
plus 5. 18 times 7 is?
Wait, what do you mean 18 times 7? 18 times 7.
I mean, the measure of angle D is 18x plus 5. So we
18.
substitute 7 for x.
126.
and
Oh,
that's
I'm doing the wrong problem.
126.
Plus the 5 is 131.
So that means both of our base angles up top are 131.
Why?
So how would I find base angles F and E?
Do the length plus.
Supplementary
measure
relationship,
equals-
good.
Yeah.
So the measure of angle F plus 131 equals 180. Subtract 131 from both sides.
49.
So the measure of angle F is 49.
Mhm.
Fantastic. And if F is 49,
Yes.
E has to be as well. Trapezoids are kind of nice, right?
No. Are
What?
they like all kind of like this though? Like
They are. I mean, all these quadrilaterals are kind of like that. So C and D, and then E and F. So now that we know the properties of our trapezoid, let's talk about, so the mid-segment of a trapezoid. A mid-segment connects the midpoints of each leg. Well, isn't that what a triangle mid-segment did? Correct. It
Yeah.
did. A triangle mid-segment disconnected the midpoints of two sides of the triangle while being parallel and half the length of the third side. Well, for this one, we've got to deal with two base angles. So instead of just being half the length of the third parallel side, it's going to be half the length of the sum of our two bases. So our midsegment's EF, which means it's parallel to both bases, AB and DC. And its length is equal to half the sum of AB and DC.
That's really complicated.
Is it?
I think it is.
Add the bases, divide by 2.
It's like, why can't you just find like the half of, why can't you just find the midpoint between the two things? On like a, because it was like 23 and then like 28, just be like 26 or something. Actually,
Isn't that what we're doing?
but it's like a really complicated way to do it, I think.
So how do you find the average of two numbers?
I mean, you add them together and you
Just divide by the
yeah,
number of numbers.
yeah.
So the average of the midsecond would be add the two bases.
I mean, I know the
You divide
formula.
by
I
two.
get the formula, but it's like, I can't just.
Isn't that what we're just doing?
It is, yeah. I think it's easy to just, I don't know, like.
Isn't it funny how math just kind of connects in all these different ways? I love it. Math is so awesome.
Doesn't mean you choose that.
Yes. So let's find a couple lengths, and then I'll set you free. AB equals 7 and DC equals 31. Find the length of EF. So we're just going to use our handy dandy formula that for some reason our man's so against. Apparently a trapezoid stole his candy one time at Halloween. I don't know. So we're going to substitute what we know. What's the length of AB? 7. The length of DC is 31. And then, of course, that's divided by 2.
So just add them together, divide by 2.
Add them together and divide them in half. Yes, sir?
Isn't
Yes,
EF
sir.
What's that?
Isn't multiplying EF by 2 easier?
Well, what do we need to multiply the EF by 2 if we already know what's. If we don't know EF, then we can't multiply by 2, right?
But if you're doing it with like variables, add
Yeah.
variables.
We'll talk about that in a second.
Isn't it easier?
1000%. Yes. All right, so 38 divided by 2 is 19. Now, like you were just talking about, well, what if they hit me with the mid segment and want me to find the length of one of the spaces? So we're still, yeah, you hear that. We're still going to do our formula. So AB plus DC over 2. And then we're going to substitute who we know. So we know EF is 47. And we know AB is 41. Which leaves DC to be our variable. So like you were just talking about, if we have to find that dude in the numerator, our lives are going to get 1000% easier if we get rid of that 2 first. So you got a couple of ways you can tackle it. You can say this is 47 over 1 and cross multiply, just like we did with proportions. Or you can multiply both sides by that denominator, which will cancel out the 2 on the right. It's up to you, however you want to do it. Both ways will get you to the same answer. What are we doing? Which way y'all want to go? We're going to clear the denominator?
Yep.
Okie dokie. So we're going to multiply both sides by dose. What happens to those 2's on the right?
Disappears.
They cancel out because 2 divided by 2 is just 1. So we end up with, what is that? 104? 53.
Eventually.
Oh. Is it 104? No. 94. 94. So 94 equals 41 plus Batman. Subtract both sides by 41. So DC equals 53.
You have to write out the formula every time.
You don't have to. It's just a helpful way to help us stay organized. Number 6. Trapezoid G, D, H, J, K. L and M are midpoints. Find the measure of KJ. Okay, so this is a situation where writing out the formula may be able to help us organize our thoughts. So what would the formula be? Which one is our mid-segment?
LM.
LM, but you can't write highlighter dummy. So LM is our mid-segment, which is equal to the sum of our bases divided by 2. So it's just like going to write an essay. So you kind of do your outline so you sort of know what's fixing to happen. Just writing that out helps you kind of organize so you don't misplace something. We're going to substitute what we know. LM is 25. GH is 2x plus 11. And KJ is 6x minus 1. Do you guys think it matters if I wrote KJ before GH?
No.
Why not? It's a plus sign, right?
Yeah.
So because it's a plus sign, the order that we write the minus are the bases isn't going to be too important. If it was a minus, do y'all think it'd be important?
No.
Yes. 1,000% yes. So what should we do before we start trying to manipulate this rascal? We need to clear that 2, right? And then in that same step, we go ahead and combine like terms. So we're going to clear the term, we're going to clear the 2 and then add our linear and our constant. How do we clear that 2?
Multiply both sides.
Yep, multiply both sides by those. If that would have been a 3 at the bottom, what would we multiply both sides by? 3. That cancels the 2 out on the right. A lot of times I see what you guys get stuck on is instead of canceling that 2 on the right, you distribute the 2 and get rid of the 2, and you really just put yourself in a weird position. So 50 equals 8x plus 10. Subtract 10 from both sides. So 40 equals 8x. Divide both sides by 8 because we want to get that x all by himself. So x equals 5.
Why did you say that like a robot?
5. But they want the measure of JK, so we're just going to take that 5 and substitute it. So we got 6 times 5 minus 1. 30 minus 1. So the length of KJ is 29. Hooray!